Hello and welcome to today's lesson on temperature and the rate of reaction. My name is Mrs Kershaw and I am one of the science directors with Outward Grange Academies Trust. The first thing we're going to need to do is to make sure we've got a pen and a piece of paper to do the activities as we go through the lesson. If you've not got that, pause the video now and go and get them. Great, let's make a start then. So make sure there's no distractions around you and let's write today's date and the title of the lesson, temperature and the rate of reaction. Our learning objectives today then, our challenge will be to explain why increasing the temperature speeds up a reaction, and our aspire is to plan to carry out an investigation about temperature and the rate of reaction. Let's get started then. Can you remember the 5 factors that affect the rate of a reaction? 1 minute, let's see how many you can remember. Brilliant, how did you get on then? So surface area and concentration we've already looked at in previous lessons. Pressure is very similar to concentration, but where concentration is talking all about liquids, pressure is the same thing but talking about gases. Today we're going to look at temperature, and in a future lesson we'll come back and look at catalysts. Here we have an animation about temperature and particles. Let's have a look what happens to the particles at a high temperature and a low temperature. As you can see from this diagram, at a high temperature there were far more collisions than there was at a low temperature. In fact, it's more than double. So can you remember, why does increasing the temperature increase the rate of reaction? 1 minute, jot it down. Okay, so let's grab a red pen, and if you need to, modify your answer in case you missed anything out. So the first thing is that at a higher temperature, particles have more energy. That means they're going to move around faster and they're going to collide more frequently with other particles. Now, that's a very similar description for most of the ways in which we increase the rate of reaction. However, temperature is slightly different as it also has an extra bit. So with temperature, not only do we increase the frequency of the collisions, but when the particles collide, they do so with more energy, and more of the collisions are successful because more of the collisions will have energy greater or equal to the activation energy. If you need to pause the video to modify your answer, then do so now. In today's lesson, we're going to look particularly at this reaction, and it's between sodium thiosulfate and hydrochloric acid. This is frequently asked in exams, and you will often see the picture that's shown at the bottom of the slide. On the left hand side of that picture, you can see that before the reaction there is a clearly visible cross, and after the reaction the solution has gone cloudy. This reaction is often referred to as the disappearing cross experiment. But why does the cross disappear? Look at the reaction in the yellow box and see if you can think about why it might be that the cross would disappear. How did you get on? Did you work it out? Do you remember that in one of our earlier lessons we talked about state symbols? They're the letters in brackets that come after the chemicals. Well, in this one you can see that sulfur has the small letter S after it, and that stands for solid. So the reason the solution becomes cloudy is because solid sulfur is produced. Right, here we have a 4-mark question. State the effect the increase in the temperature of the sodium thiosulfate solution has on the rate of the reaction, and explain this in terms of particles and collisions. If we begin by bugging this question, we would see that there are 2 command words, state and explain. State is simply write what happens. Explain, we need to give a reason for that, and often to explain why something happens it's a good practice to use the connective because. If we underline our keywords for this reaction, then our keywords are increase in temperature and the rate of reaction. So we're going to need to include those in our answer. And then if we glance back over the question, we can see that we've also got particles and collisions in there. So we're going to have to make sure that we explain this in terms of particles and collisions. Time for you to have a go. 4 minutes, see if you can answer the question. grab a red pen and see how you got on. First of all, did you state that as the temperature increased, the rate also increased? Did we then say that is because the particles have more energy? So the frequency of the collisions will increase. And then finally, because more particles have energy greater or equal to the activation energy, more of the collisions will be successful. Brilliant. If you need to modify your answer at all, pause the video now. We're now going to watch a video of somebody actually doing this experiment.
Practical 3. Investigation of how the rate of a reaction changes with temperature. In this experiment, we will investigate how the rate of a reaction of sodium thiosulfate with hydrochloric acid changes with temperature. Firstly, we will have a look at the theory behind the experiment. I will then run through a demonstration of the method. Once the data has been collected, I will show you how to use it to investigate the effect of temperature on the rate of a reaction. We will finish with some key points to remember when you're doing the practical yourself. In this experiment, we will be investigating how temperature affects the rate of a reaction of sodium thiosulfate with hydrochloric acid to give sodium chloride, sulfur dioxide, and sulfur. During the course of the reaction, a precipitate of sulfur is produced. We can monitor the rate by measuring how long it takes for a fixed amount of sulfur to be produced. This fixed amount can be thought of as the amount of precipitate that would result in a cross underneath the reaction mixture to be obscured from view. We can time how long this takes to happen. Before you commence any practical work, it is important to consider the health and safety risks associated with the experiment. Risks could arise from the materials or apparatus you are using. During this experiment, you must wear gloves and safety goggles. This is because hydrochloric acid can cause skin burns and eye damage. Toxic sulfur dioxide gas is produced during the reaction. Take care not to breathe in the gas. If you are using a hot plate or Bunsen burner to heat the water in your experiment, ensure you do so safely as to avoid burns. The apparatus you will need to complete this experiment is shown here. I have used a plastic container with a lid that has 2 holes in as a water bath. However, your equipment may differ slightly. I have placed a piece of paper under the water bath. There is a cross on the paper underneath the test tube on the right. Before you begin your experiment, construct a table of results like I have done here. You will need to record the initial temperature in degrees Celsius, the time taken for the cross to disappear in seconds, and the final temperature of the reaction mixture. The experiment will be repeated at 5 different temperatures, so that the effect of temperature on the rate of reaction can be investigated. For the first experiment, we will not heat the water. Measure out 10 centimeters cubed of 1 mole per decimeter cubed hydrochloric acid using a measuring cylinder. Check that the meniscus is at the 10 centimeters cubed mark. Add the hydrochloric acid to the test tube on the left. Now measure out 10 centimeters cubed of 0.05 moles per decimeter cubed sodium thiosulfate solution using a measuring cylinder. Check that the meniscus is at the 10 centimeters cubed mark. Add the sodium thiosulfate solution to the test tube on the right. Lower the thermometer into the test tube on the right. Wait a few minutes so that the temperatures of the liquids in the test tubes and the water bath equilibrate. Write down the initial temperature and add 1 centimeters cubed of hydrochloric acid from the test tube on the left into the test tube containing sodium thiosulfate solution. Start the timer and record how long it takes for the cross to disappear. Record the final temperature of the reaction mixture. Pour the contents of the test tube containing the reaction mixture into the sodium carbonate solution stop bath. This will stop any more toxic sulfur dioxide being produced. Acid in the reaction mixture will be neutralised. Repeat the experiment at 4 more temperatures. Use a kettle to add hot water to the water bath, making sure that the temperature does not exceed 55 degrees Celsius. After adding hot water, always wait a few minutes to allow for equilibration. You should now have a data set that looks like this. The temperature at which each experiment was carried out at must be known as accurately as possible. Therefore, you must calculate the mean temperature. This will be used when plotting your graph. The initial rate of reaction is equal to the amount of sulfur produced divided by time. Therefore, the initial rate of reaction is proportional to 1 over time, as the amount of sulfur being produced is fixed. Work out 1 over time for each reaction and add these values to your table. As you can see from my data, this gives very small numbers that would be difficult to plot. Work out 1 over T times 1000 and add this to your table to make the graph easier to plot. Plot mean temperature in degrees Celsius on the x-axis versus 1 over time times 1000 on the y-axis. Your graph should look like this. As you can see from the graph, a small increase in temperature results in a large increase in rate of reaction. This is because at a higher temperature, there is an increased number of particles that have energy greater than or equal to the activation energy. The purpose of this experiment was to investigate the effect of temperature on the initial rate of reaction. To do so, we timed how long it took for a fixed amount of sulfur to be produced at different temperatures. When doing the experiment yourself, remember to calculate the mean temperature for each reaction. Plot this against 1 over time times 1000, as this is proportional to the initial rate.
We are now going to plan an investigation to show how the temperature of the sodium thiosulfate affects the rate of the reaction with dilute hydrochloric acid, and we need to ensure that our plan will give us valid results. So if we bug the question, this time our command word is plan, and that means write a method. Our keywords are temperature and rate of reaction, so we're going to need to write a method that changes temperature and measures the rate of reaction. And then we need to remember that we have to produce valid results. And the way that we produce valid results is making sure that we control the correct variables. These can be worth 6 marks in an exam. As you can see from the grid that we're displaying now, to get to level 3, the method would lead to the production of a valid outcome. When you see this in an exam, it means that you must list the control variables. Also, to gain a level 3 and get 5 or 6 marks, you would need to make sure that all your key steps are identified and they're logically sequenced. So let's have a look at how we might plan to do this. Here I have a grid. The method, I would always recommend that you use bullet points. If we think back to that level 3, it needed to have a logical sequence. Using bullet points will make that very clear to the reader. Apparatus. I would always favour drawing a diagram and labelling it. Students often say to me, but there was no space to draw a diagram. It doesn't matter if you have a page and a half of lines, you can still draw a diagram on lined paper. Lots of students forget the risks. You need to say what the dangers are, but also how you will prevent them. And then finally, the variables. Our independent variable is what we will change. In this case, that will be the temperature. The dependent variable is what you will measure, and in this experiment that will be the time taken for the cross to disappear. And then critically, the control variables, what are we going to keep the same for every reaction? So we change the temperature, but everything else must stay the same. So things like the volume of hydrochloric acid, the volume of sodium thiosulfate, the concentration of hydrochloric acid and the concentration of sodium thiosulfate. We must never in these experiments talk about the word amount. Examiners do not credit this, so we must talk about volumes and concentrations. Bearing these in mind then, and the fact that these are worth so many marks on an exam, it's always worth spending some of your time planning. So we're now going to spend 3 minutes planning your answer. Now that we've spent 3 minutes planning our answer, we can spend time writing our answer in full. Remember, it's a plan, so it must have a method. Our keywords are temperature and the rate of reaction. So temperature is the independent variable that we will change. And we must have valid results. So we have to list our control variables. A good way of writing a clear, coherent plan is to use the 4 sections of MARV as subheadings. So draw out your equipment and label it. Then the first part of your method, you can just write set up the equipment as shown in the diagram. Then you can give step-by-step instructions. Don't forget to list your variables. Do not forget to list the risks and how you will prevent them. 5 minutes to write your plan. let's make sure that you got the key points then. So first of all, we would need to make sure that you measured an indicated volume of sodium thiosulfate. That means they were expecting you to write a volume. 50 centimetres cubed would be fine, anything up to that. Place sodium thiosulfate in the conical flask. Measure 5 to 10 centimetres cubed of hydrochloric acid. Place the sodium thiosulfate on the cross. Add the hydrochloric acid to the conical flask. Swirl it and start the stop clock. You then need to measure the time for the cross to become no longer visible or for it to disappear. We'd expect you to get a level 3 answer to say that you would repeat it and that you would find the mean, and that finally you would then repeat the whole process for different temperatures. And you may find it easier in your method to actually state what those temperatures are. So you might do it at 20, 30, 40, 50, 60, 70 degrees centigrade. We usually say 5 different readings is a good range to have. All that said, if we didn't get the next points, then we don't get a level 3 answer. So we must have our control variables in there. So did you say you would control the concentration of the hydrochloric acid, keep it the same every time, or the volume, or the volume of the sodium thiosulfate, or the concentration of the sodium thiosulfate? I'd really expect to see at least 2 of these to be present if you were going to access a level 3. Okay, so that concludes our lesson for today. Well done, everybody. If you'd like to write some more notes, then the following slides have a summary of what we've covered today. If you wish to record this in your book, you can do so, and you can pause the video as you go along if you need to. Bye.